A very good morning. We will be starting with module number 1, which talks about basic database concepts. Now, you might be wondering, what do you mean by a database? Now, before we think about what is meant by a database, let's see a few applications of databases which you see around you. Like, you go to the ATM machine, money comes out. That is an application of a database management system or a DBMS, because all your account details, all the customer details, everything will be stored somewhere. And then you, as a simple user, you go into the ATM, you put in your card is verified, and then you get money. Your gaming, that is again another application where your scores, there are thousands of users, all their scores, all their levels, all their latest status, everything is being stored. You go shopping, Amazon, Flipkart, or eBay, whichever shopping site, you have an array of products. You have a concept called cart. All those data, they are being stored somewhere. And that somewhere is actually what you mean by a database. Imagine you're doing a ticket reservation, be it flight, or be it your train journey, or be it your red bus. Okay, you will be able to get a ticket for a particular date, for a particular route from the data which you see on your screen. And all these data, they are maintained in a database. Let us now see a few very simple terms. The first and the most important term you need to know is, what do you mean by data? Data is raw facts or figures which actually give you no meaning. Now, if I tell a number called 20, it has no meaning. But when I organize it and when I say age equal to 20, it gives you a meaning. Now, this I call it to be information. When I process it, when I process my data, I call it to be an information. I can even give another meaning for this. I can say cost equal to 20. It is a different meaning. This is another set of information. So data as it is a raw fact or a figure which, when organized, may be transformed into information. You even have another term called database. You might be having one age as 20, another student's age, it might be 22, another student in your class might be 23, another might be 18, and another might be 19. Now, you need to store data like, let's say, Akhil's age is 20, Anand's age is 22, Annette's age is 23, Shruti's age is 18, Jacinta's age is 19. You need to store this somewhere. Now, the concept where you collect all these data together, organize it. Now, I've arranged it very well. I can make it as rows and columns. I just have a single column over here. I've got 5 rows, which means, I have 5 students' details. I've made it into an arrangement. I can call this, let's say, I can say it is in a table format, a table which has one column and 5 rows. I've arranged it so that, it gives me some meaning. Now, that kind of data collection to meet the user's needs, you call it database. Now, this is not the only table I can have. This is, I'll say, table number 1. I can have another table called table number 2, which might be storing your addresses. I can have a table number 3, which stores all your educational details. I can have another table, let's say, table number 4, which gives you all the courses in Rajagiri. Okay, so I can have any number of tables. Now, all these tables together, I will put it together. Okay, table is nothing but a structure in which I did my arrangement of the ages. Now, all my tables together, I've got 4 tables over here. I put them together I will be calling this collection of tables as a database. So a database is nothing but a collection of tables or a collection of data so as to meet a particular need. We'll go for another term called DBMS, Database Management Systems. Okay. Now, as I told you, you have n number of tables. You have stored everything into a database. Okay. Now, let's see, what do you mean by a database? Now, imagine I want to find an answer for how many students are less than 20 years of age. Okay. How many students are less than 20 years of age? Or how many students have a percentage between 50 and 60 during their graduation? Okay. Now, to find answers for these two questions, as I told you, you are having a DB which has tables called T1 to T4. And in some age table, you store the age details. And in some table, you are even storing the mark details. Now, with the help of a program, you need to find out answers for this particular question and this particular question. So, DBMS is nothing but a group of programs that manipulate the database and give you answers for your particular questions. That is what exactly we mean by a DBMS. Let's now see a formal discussion about what do you mean by a database or what are the functionalities of a database. Now imagine, like, a few people were telling that supermarket is an application of a DB. Okay, think about supermarket. You can think about your online Lulu supermarket, Lulu hypermarket. Okay, you have Lulu hypermarket where you can shop, where you have n number of products. Okay, let's say you have tomatoes. You have tomatoes and the price of tomato is 20 rupee per kg. And then even you have bananas whose price is 50 rupee per kg. Now, this is of 1st September. Okay, on September 1, tomatoes are 20 rupee and bananas are 50 rupee. Let's say September 2, you still have the same products, tomato and bananas, but the cost has changed. Tomatoes price dropped down to 15 and bananas, let's say it is now 55. As you all know, this is stored in a table. The same table itself, you have to modify the values. So DBMS, they should be capable of not only storing, but also modifying. And you should be even able to extract. What do you mean by extracting? Extracting means retrieval or getting data. Like, imagine I am asking a question. Which are the products in Lulu hypermarket which have sales of greater than 500 kg per day? A very simple question. Which are the products, or I can be very specific. Which are the fruits? Okay, which are the fruits which have a sale of greater than 500 kg per day, which means, they are the fast moving products. So I want an answer for this particular question. Now, getting answers for questions, you call them by the term extracting. So DBMS, the programs, they should be able to store your data, modify your data, and even extract your data. Now, DBMS, it need not always be huge. Now, imagine you're having a small electric shop in your village. Okay, I have an electric shop, let's say light electricals or bright electricals in my village. In my village, it just have 30 products. It has only 30 products, and that's it. A very small shop of, let's say, 200 square feet, a few shelves, that's it. Okay, now I need not go for a high-end database. I can be happy with a small system. I need not have many machines because the guy who runs light electrics, he just has an old desktop, and things should work happily over there. So it can be a small system, or imagine about Amazon. Okay, Amazon, you have Amazon India, you have Amazon US, you have Amazon UK, you have Amazon Canada. Think about any country in the world, you have Amazon. Small systems will not work. You will have to go for big mainframes. So DBMS, it has a huge range. It can be from the small electric shop in your village up till Amazon world over. So, you were talking about various databases like library systems, ATMs, flights, inventory systems in supermarkets and all that. Now let's see how databases were long back before. Earlier databases, they weren't very sleek. You had to have huge systems to run your databases, but now things have changed a lot. Now what happens is, I have a very simple example. I've just taken a Flipkart. I was into planning a dinner set last week, so I just directly took that screenshot. Okay, so this is a Flipkart screenshot. So this is how databases work nowadays. I simply type over here dinner set, or let's say crockery. I click a search. This is actually, I'm extracting. I am extracting. If you remember the functions, you store, you modify, and you extract. Okay, when I type in something over here and I click the search button, the screen appears for me. I am extracting data. Now look here. I've got a price of 4,999. As of yesterday, they were giving me an offer and I need to pay only 3,295. But day after tomorrow, when I open up the same site, this 3,295 would have been something like 3,995. That is where I modify. Not I modify. The database people of Flipkart, they modify stuff. Okay, so extracting, modify, and then storing stuff. So this is how now advanced databases work. All these are possible, and usually you will be having it in a table structure. A table is nothing but you will have rows. This you call it a row, and you will even have columns. We will learn about that later. Table is nothing but a collection of rows and columns. Earlier you were having big machines to store your DBs and all. Now you have sleek machines. You have sleek machines with high computing capacity, where you can either store it in these kind of individual database servers, or if you look over here, when you go for big applications like Amazon, or you go for Google and all that, small machines will not be enough. You will have to go for big server rooms where all your data is being stored. And that is why even, you might even have heard about a term called Google Farms. You can do a Google searching, or to be very specific, data farms. FARM. You can do a Googling search about what do you mean by a data farm. Okay, so this is what you call data center. You might have come across these terms. Data center, where loads of data are stored, especially when you think about Amazon, or when you think about big banks like State Bank of India, HDFC, and all that. There are millions of data which has to be stored. All these are stored in databases and in these data centers. So this is how databases are now. Now let's see about hierarchy of data. Now, you might be remembering all this. Bits, 8 bits, make a byte, a character. You remember all this in your bridge courses. We have a concept called field. Okay, a field is nothing but word, group of words, or a complete number. Now imagine I write something like this. Umesh, 23. Umesh is a field. 23 is another field. Okay. Record. A logical group of related fields. So, I can make this related. Now, these are individual. I can say name Umesh, age 23, and I can say this is a record. You can think about the ID card. ID card is a record. Okay, so I've grouped everything together. I've done a logical grouping. I can even have his address. I can even have his phone number. I can have his Aadhaar card number. I've grouped all of Umesh's details together. I call this to be a record. Okay, now this is just one record. Okay, now I have a concept called file. I have a concept called file. Now, this is just Umesh's, okay? I have Umesh's record. I will even have Dinesh's record. I will have Rehan's record. I will have Akhil's record. All these are personal details, okay? All these together, I will say it is a file. A file which has all the personal records of, let's say, 4 people or 40 people or whatever. Okay, so this is a field, this is a record, only Umesh's. Now, I do have a file which has the personal record of 40 people. When you go to the hierarchy, you have something else called a DB, which you will have the personal record of 40 people. Okay, you will have the financial record of, let's say, 45 people. You will have the traveling records of, let's say, 200 people. You call this to be a database. I'll just show you a small figure so that you get it a bit more understandable. Now look here. You might have all be very familiar with the address book. Okay, now look here. I have details of many people over here. Now each of this, the name is a field, address is another field, city another field, state another field, and so on. So each of these, 1, 2, 3, 4, 5, I say each of them are fields. Okay, this is the record of Daniel. This is the record of Fred. This is the record of Tom. This is the record of Jeff, and so on. So a record is nothing but a collection of logically related fields. Now, if you think about all these records together, imagine I do have 58 students in my class. Okay, all these 58 students, their details, I put it in a single address book, or I say I'm either putting it in a file or I am putting it in a table. Now, what is the difference between a file and a table? I will tell after some time. But anyway, I have an address book where I do have records of many people. I do have record 1, record 2, up till record of 58 people. All that together, I call it to be a file, or a table. Now you might be wondering, what is a DB? What is a database? Now, as I was telling you, I have the address book of 58 people. Okay, I can have the fee detail. Fee detail is not told over here. The fee detail of 58 people. Okay, the traveling detail of my 58 people. Okay, I can have the course details, electives, everything of 58 people. So each of this is a table. This is a table. This is a table. This too is a table. This too is a table. A collection of many tables together or many files together. I call it by the name database.